Good afternoon, everyone. Thank you for coming along to the July RTD webinar. We've got another update on Asset AI today. So we've done quite a few of these over the years. We tend to try to do them on about a 6-monthly basis just to give you a bit of an ongoing update of the project and how it's progressing. So Nathan Skelly, who's the project manager from our side on this project, will be leading the presentation today. So I'll pass over to Nathan in a minute. Just quickly, for those who haven't been to one of our webinars before, it's in the town hall format. So unless you're a staff member, you won't have access to the camera or the microphone. So if you do have any questions or comments as we're going through, we have both the chat and the Q&A function available in this session. So please post your questions or comments in one of those avenues, and I'll keep an eye on them as we're going through, and we'll do a moderated question session towards the end after Nathan's done his presentation. So look, without further ado, I'll pass over to you, Nathan, to kick us off.
Thanks, Josh. Welcome, everyone. Thank you very much for coming to listen to me speak on Asset AI. So I've been working on the platform from IPWEA's side for the last 12 months now. Prior to that, I was working on it as a council user at Liverpool Plains Shire Council, where I brought the platform to use at Liverpool Plains Shire Council and started using it and seeing what benefits we had from there. Previously, IPWEA has done a benefits report that focused on the qualitative benefits, so how councils were using it, what they were doing with some of that data, but it didn't focus on the dollars. This one has focused on the dollars potential savings that can come from using Asset AI, being more proactive with the maintenance management and the cost reduction for inspections. So first, I'll just give you a bit of a rundown on what Asset AI is. So the way we do data collection is you have a camera provider that the cameras installed on vehicles. They can either be already on the network, being garbage trucks, street sweepers is a prime example, or some of our councils do use them on bespoke inspections. You drive around at the prevailing speed limit. There is no intervention needed from the driver of the vehicle, and it picks up footage or images and then runs that through an AI classifier to identify defects that are on your road network. Now, the different providers can identify different defects, but the majority of your more common defects, particularly for routine maintenance, are picked up by this platform. When it comes into the Asset AI platform, we undertake what we call a deduplication of defects. So one of the challenges with AI is it picks up a lot of defects, and our data providers, for the most part, don't actually deduplicate them. So without that process, you will potentially get a number of detections of the same defect multiple times to try and filter through. We do that filtering for you. So when you see defects on your screen, it will be the only defect in that area for that type of defect. We also do auto closures of defects on the platform. So we use the information from the detection cameras to identify which defects have been closed over time and then close them off the platform. So what you will see at any given time is a pretty good live representation of what defects are on your network. It also does severity tracking of the defects and also counts how many times it has been seen with a history layer in there as well. On the AI analysis piece within the platform, we have what's called a defect susceptibility index. What that is doing is it's looking at your defect history and a myriad of other data sources to make predictions on which segments of road may exhibit cracking, potholes or rutting over the coming 6 months. So it's trying to give you a forward-looking view of which parts of your road network might exhibit defects into the future. From that, it is a lot of GIS data. So we have a system that has multiple filtering options to get your defect data down to an actionable level. And it's one piece of work we're doing a lot on for the next phase, is to really sharpen up that workflow from detection through to closure within the Asset AI platform. We also ingest layer of data from a company called Compass IoT. They provide us with anonymized data from private vehicles on the road network. So anything post about 2017 is potentially eligible. Most of these are fleet vehicles that have opted into sending the data. So from that, we get accelerometer information that we can use to give you a proxy for roughness of your road network where those vehicles travel. They do travel a lot of the state. It's quite surprising how far they go around. There's about 30,000 of these vehicles across New South Wales, and there's even registers of them out near Broken Hill. So they do get around a lot of the state. So for Asset AI, this project started in about 2020 with the initial idea came from Canterbury Bankstown Council, which the theory was we have garbage trucks driving our network. What if they could do road defect inspections? So that's where the premise of this whole thing started. We did some investigative works on that side of it in the initial phase, and identified that there was an opportunity for this platform to work. And then we managed to get funding through Transport for New South Wales to deliver this over the last 4 years, and we've got funding moving forward for the next 3 years. We have 19 councils on board now. They're spread across the state and spread across different types of councils. So you've got the small rural councils, the large metro councils, and everything in between. Our current development partner is Sign Advisory. They've been on the platform with us since February, and we've got nominally $2 million a year to do development work for this platform. So we're working with them on our first full phase of development with Sign and building out new use cases and new analysis to try and help the councils on the platform better manage their roads. So what I'm here to talk about today is the quantitative benefits report that I did. So looking at dollars. So I did a lot of analysis over the defects that are on the platform. So we have this data is looking from 2024 through 2025, so from January through to December, so 2 full years of data. It's across 12 councils worth of data on that time, and councils were coming onto the platform as we went through. So some of it, we've looked at time series analysis, but mainly I'm looking at cuts of percentages rather than total numbers, because total numbers consistently increased as more councils came on board. There was 800,000 defects that I did this analysis over. I've looked at them by segment, by severity, by time, by where they are on the asset hierarchy, by what defect type they are, and tried to identify where there is efficiencies for councils and demonstrate what councils have been telling us. They've been telling us it's saving them time and money, and seeing if I can show that through the data. A very high level snapshot of what the data shows across all of the councils on the platform. High severity defects, so those that are severity 3, 4, and 5, decreased over time. So that would indicate the road network's getting better. Now, is that because we're doing better maintenance? Difficult to say. It could be because it hasn't rained. We couldn't really account for that part of it. Defect deterioration, so defects getting worse, going from severity 3 to severity 4 to severity 5. That one slowed a lot, and you can see in a later slide and in the report, you can see that councils were increasing their focus on high-risk defects, which is the benefit of having that data. They can prioritise where they spend their maintenance money. Defect closure time also reduced from over 200 days to under 100 days. Now, it's important to note with that metric in particular, that's not repair time. That's how long it takes from when the defect was initially detected to when it was automatically closed on the platform. And there is a lag of how long it takes to close it on the platform, because we have to have a number of passes of a non-detection before we deem it closed. So it's not how long it took to repair, it's just how long the platform took to close it. And then we also had nearly 60,000 defects that are known to increase crash risk repaired over that same period. So one of the main things councils are telling us is that they are seeing cheaper inspections as part of using this platform. So multiple councils have done very different things. There's a handful of councils that we worked with that were already doing inspections and have now seen a dramatic reduction in cost, depending on how they're using the platform. The likes of Canterbury Bankstown, in the urban area, they've got all their cameras on street sweepers, so their costs have plummeted by defect detection. They managed to inspect their entire road network every 2 weeks just by their street sweepers driving around their network. Another council, which is a small rural council, went from not doing inspections at all to now doing quarterly inspections using this platform. And I believe they often send an executive assistant out or something like that to drive the network, because there's no intervention required from the operator of the vehicle. Another large regional council has halved their inspection time. So what that's meant for them is they haven't reduced their staff numbers. They've gone and inspected more assets and are now able to signpost high-risk defects. So they're getting more done with the same team, but their road inspection time has reduced by about 50%. So when you look at that potentially across the state, there is potential efficiency gains of some $36 million across the entire state moving to Asset AI defect inspection. So without Asset AI from the participating councils, the inspection cost was approximately $345 per kilometre of network annually. And then those councils with Asset AI are now spending about $144 per kilometre annually. So it's 50-60% reduction in cost. Again, if you can put it on your street sweepers or your garbage trucks where they can collect the data really quite autonomously, there's no intervention, there's nobody driving around with it, and it's just an adjunct of the work they're doing. We've seen detection costs reduced by almost 90% in those instances as well. But acknowledging it's unlikely you would send a person out to inspect the road network every 2 weeks. So they're getting far more data, far more frequent coverage, at a much lower cost. Now, a lot of what councils are telling us is they're managing their defects better. So they're seeing the defect data that they have, they're able to better plan what they're doing and better identify where to spend their money. The previous benefits report we did looked into how councils were using that. I participated in that one through Liverpool Plains Council. We did reseal planning using the data from Asset AI. We had a new staff member on, didn't have a lot of knowledge on our network, and they were able to quickly look through the defects in Asset AI and identify segments for reseals in the first 2 months of their time there. And it was really quite the time saver to shortlist those defects. What we've done through this one is tried to look at that defect level maintenance work and how councils are doing about it. They're telling us they're doing it better, and see if we can reflect that in the data and then try to assign a cost value to it. As I previously mentioned, defect severity trends are going down. We are picking up less severe defects on the platform and they are deteriorating less as well. So they're getting repaired before they're deteriorating, which is a positive outcome. So we're identifying the defects and we're repairing them before they're getting worse on the network. And that was pretty common throughout all the councils individually, but also when you aggregate the data, you can see that the trend is going down. Now on the deteriorating defects one, you might notice the graph cuts off earlier. Part of the reason for that is I cut the data off in December 2025 and I stopped this analysis in June 2025 because it didn't make sense to me to show that the defects detected in December were deteriorating because they haven't had an opportunity to. So on the deteriorating defects, the data's cut off earlier to give it 6 months time worth for the defects to deteriorate before I could determine they deteriorated. On the maintenance planning, councils are telling us that they're better at planning their maintenance and that they're more efficient at getting the defects to their teams to repair. So looking through the data, I was trying to come up with a method to see if I could demonstrate that in the data. Now, what we have within the information is all of our defects are identified to a specific segment in the platform. It doesn't necessarily line up with council segments, but there are unique segments throughout the whole platform. So what this chart's looking at is the defect intensity by segment and the repair intensity by segment. So on the left-hand side, you can see the defects detected by segment has been trending down from the start of 2024 to the end of 2025. So we're seeing less defects per segment, which when you look at the reduction in risk rating would indicate the network is improving. So that's positive outcome. Again, we haven't really accounted for weather, but that's what that data is showing at the moment. On the graph on the right-hand side, we're seeing that repairs by segment have increased over the same period that detections have decreased. So what that's showing is councils are more efficient at planning their works using the data through Asset AI. They are aggregating defects to get the work done in a more efficient manner. They are doing broader treatments on segments where they can identify multiple defects of the same type. They're focusing on better treatments at that point because they have that data available for them. So that's what the council's been telling us, and certainly what I witnessed in my time at Liverpool Plains Shire Council. This demonstrates the same sort of, this data demonstrates that that is what is occurring on the broad level of the network. And again, going down to individual council level, you can see some of the councils have even more pronounced effects of this, like more pronounced showings of this behaviour, and it's generally those that are far more actively using Asset AI to plan their work. So from that, the question is, how much value does that save? Now, this was one of the biggest challenges of this entire report for myself. I was doing a lot of research into the reduction of how intervening earlier, can reduce your long-term maintenance costs. Within the engineering fraternity, it's known, it's accepted. We have graphs like the one on the right there that's in the International Infrastructure Management Manual that say if we do more proactive maintenance, there's a lower cost of total life cycle cost. The challenge I found looking through the literature, there wasn't much around focusing on reactive maintenance works or routine maintenance works more correctly. There's a lot of information around resurfacing of roads, so resealing, resheeting with asphalt. There's a lot of information around that, but there isn't much around how much cheaper a proactive repair is to a reactive repair. So I struggled to find anything within Australia that identified that. I had a discussion with IPWEA's National, Steve Verity, to confirm, see if he could give me any guidance, and he confirmed my discoveries as well, that there's not a lot of information within Australia on that. I then looked a bit further abroad. So the UK does a report every year they call the Alarm Report. I can't remember the acronym off the top of my head, I apologise. But it's looking at road repairs over the entirety of the UK from different road authorities. And they've been doing this report for 30 years. It's akin to IPWEA's road asset benchmarking report that we do as well. It's a similar sort of format. It had some information on the costs of proactive maintenance versus reactive maintenance for potholes in particular, where they've identified that proactive maintenance costs 35% less per pothole repaired than reactive maintenance does. They also make a claim that the optimal reactive proportion is 15%. There's no evidence about how or why that might be the case. I've seen figures between 15 to 30%. Again, I've not been able to find any real studies to show how or why that number's come about. Within our participating councils, about 77% of the work was reactive compared to when you normalise it to how the UK method did it. So one council in particular had a lot of information on what inspections they had done or how they'd done their work and how many defects they repaired. They weren't doing routine inspections, they were doing pretty reactive work to that. So I use them as a metric to look at it. So you're looking at about 77% of our work was reactive. Thank you, Ross. That's correct. That's the one. We also did some work from one of our participating councils on how much you might be able to save on materials for pothole patching. By intervening earlier, you can save approximately 75% of your material costs. So what I've done is I've then put all these figures into, done analysis looking at the percentage of roads the councils on the platform have to what the state network might be, and then normalised repairing maintenance through a reactive versus proactive. So essentially for any given defect, the proactive cost is 0.65 of the reactive cost. So that's how I've kind of addressed that issue. And then I've put it across the $479 million spend that councils do in New South Wales on maintenance alone every year, and looked at what potential savings could be across the state for moving more from a reactive maintenance to a proactive maintenance. So the values get quite big quite quickly when you start looking at that. So you're going from about $14 million annually up to about $42 million annually. Since I've drafted the benefits report, I've found another piece of information where an American Department of Transport moved from 25% proactive maintenance up to 80% proactive maintenance through use of a GIS-based maintenance management system. So specifically the likes of an Asset AI product, where it's location-based, GIS-based, and you can really map out where your challenges are. They've managed to move from 25% proactive to 80% proactive by really focusing on that using a GIS defect management tool. So the next one we looked at was defects, the impact of defects on safety. There's a lot of evidence that defects give rise to a crash risk. However, there is not a lot of linkage of accidents to road condition for the most part. Within Australia, most of the accidents are listed as driver causes or off-roading to object, whatever the case may be. Not many of them actually identify road condition as a risk. Australians have done a lot of work on this. You can see some figures there. You can see a 24% increase in crash risk from low skid resistance. So within Asset AI, that could be flushing, stripping, raveling, could cause a low skid resistance. Now, Austroads is very clear that occurs on bends. Obviously, there's not low friction, doesn't matter too much on a straight unless it's a braking incident. Rutting depth, if it's over 20 mil, increases crash risk by 25%. So these are defect types that are known to increase crash risk. Statewide Mutual have personal injury claims and property claims related to potholes as 30% of their total claims in any given year. It's a big issue that is across the state, and it is something that there's not a lot of information around how that works and what the impact is. Looking at those defect types, as I said before, there's about 60,000 have been repaired in the 24 months of this data. And again, we've got the severity reducing. The defects are lasting on the network for less time. We have better defense under Section 42 because we have clarity on what the severity of the defect is, when it was detected, where it is, what the history of it is, how it's evolved over time. And then you've also got inspector safety as a benefit as well. Now, a fatality is worth approximately $9.3 million. It is not possible for me to prove a counterfactual with this report. I can't prove that any works that have been done has reduced a fatality. It's not possible to make that prediction. All I can prove is that the risk on the network has been reduced through improved repair times and repairing things at a lower severity level. So we have reduced the risk across the network for crashes through the use of better defect maintenance planning. This one isn't actually in the report, but this is the sort of data insights you can get within the Asset AI platform. So this is two separate councils, and I apologize, it's a little bit difficult to see, but I can talk you through it. So there's two separate councils. They both are rural council, and you can see they've got vastly different defect types that are dominant within their network. So for the council to the left, the dark green that takes up the most of their bar is edge breaks. So for that council, edge breaks are their predominant defect type across their entire network. It's 40–50% of the defects they identify are edge breaks within their network. For the council on the right, the light blue there is flushing. So again, you've got two rural councils. You would think their defect types would be somewhat similar, but the dominant defect type for them is the flushing defect, not so much edge break. So looking at this data, you can start to identify where your maintenance spend would be best focused to reduce the recurrence of these issues. So, you know, for the one on the left, potentially they could do a massive edge break program to fix it. There might be line marking that needs to be done, or alternatively, it could be a road widening issue for the most of them. For the council on the right with flushing, they probably should look at how their reseals are being done and how they're planning out their reseals, what they're getting delivered, whether they're using the right materials, whether they're using the right process, and try to better manage that to reduce those defect types. This is what you can see when you have this level of data. It's not been economical to collect it. If you weren't going to do work on it, you never used to collect this information, whereas now you collect it just by driving around on your network, and then you can start to look at what opportunities there are to improve your network and improve how you do your maintenance based on the defect types that you see a lot of. Similarly, this one is within the report, but this is showing how councils are focusing their repairs. So the one on the left is looking at repair time by hierarchy. So we can see for the most part, it follows the hierarchy perfectly until you get to local roads. So obviously we're seeing that they're repairing defects on busways, motorways and highways more quickly than they are on the local roads and the local access roads. So again, it shows that the councils on the platform are focusing their effort on the areas of the greatest impact, being those higher priority roads. Then on the right, we have a list of defect repairs by severity rating. So you can see on that one, red in this instance is severity 4 and 5, yellow is severity 3, and green is severity 1 and 2. So you can see over time, they're getting more of this high severity defects done, which aligns with the data we showed earlier. They're better focusing on those high severity defects, reducing that risk for their road users. They are still getting the low priority defects done, which is fine. Some of these are opportunistic ones where you're repairing one defect that is severe, but there's another one nearby that's low. You just repair it in the same time frame whilst you're there. If we look at the total value across the entire state, if you take the optimistic estimates of everything, there's potentially $78 million worth of value that could be unlocked across the state through inspection efficiencies and maintenance efficiencies improvement. Now, the road asset benchmarking work that IPWA does says there's about $164 million annual funding gap. So we don't close that gap, but there is the opportunity to move further towards it. We spend $479 million annually on maintenance across the road network in this state. It's a huge spend of money. So you don't need massive efficiencies across the entire state to see large gains in dollar value. And this was done to try and help promote to Transport for New South Wales to continue to fund this program as well. So they're obviously putting a lot of money into it and they're asking the question, well, where's the value for the state? And this is where this piece of work has come from. I do have a calculator that I've developed in an Excel sheet that I'm happy to share with anyone who wants it, where you can enter in your council's details and it will give you an estimate of what the potential saving could be for your council based on the same numbers that are within this benefits report as well. So if anyone does want that, please feel free to call out and I can send it through to you. So for Asset AI, our next steps are focusing on development with Sign. We are doing a lot of work to improve the ease of analysing the defects within the platform. From those on the platform, one of the key feedback pieces we have is there's a lot of data, and there's no two ways about it. As you can see, across 12 councils, there was 800,000 defects in 2 years. There is a lot of information. So we're working with Sign and the councils on the platform on how to better display that data and give them better insights into what they should be focusing on. So some of the things we're looking at is doing trend analysis. So where defects are increasing, where the severity is increasing, which segments have more defects on them. We're looking at giving you information on where your roads have been inspected, so you can make a judgment call on where to send your crews to inspect the road network, because at the moment it's a bit anonymous with the automated collections. You don't necessarily see where your team's gone. And we're also building out a work order workflow within there so that you can maintain the defects from detection through to closure within Asset AI. So what we're finding with a lot of councils we're talking to, they're not currently undertaking inspections. So when they pick up the Asset AI platform, they've got this brand new data source that brings in a myriad of defects that they've not actually got a system in place to deal with it. So we're building out easy to use workflow management for that within the platform. The next phase, which is going to run from October, is looking at improving our Tech 1 integration. We do have 2 integrations at the moment. We integrate with Reflect, so you can send defects detected through Asset AI through to Reflect on both local and state roads. For the state road one, you can talk with your contract manager, but there is support to use Asset AI on your state road networks as a trial basis. It doesn't do all of your inspections. It can't do your culvert inspections. There's some constraints on what it can and can't do, but it is something you can use along your network to start that process and try and streamline your inspections on RMCC. The Tech One integration, same sort of thing. We can send defects across to Tech One, then you can allocate it to a work order, send it to your team to get it repaired. So if you're using Tech One or Reflect, we do have an integration into it for that work order flow. We're just going to improve the Tech One integration towards the end of this year. We're also looking at what we can use the data for in terms of identifying road safety insights. So I mentioned previously the Compass IoT data. We have accelerometer data there, which means we can also look at when people are braking or accelerating or cornering hard. So we can find those outliers and potentially surface them to you to say, hey, this section of road has a very high likelihood of crashes because of increased braking force, sharp cornering, whatever the case may be. So we can try and flag those up to you as part of it as well. Another piece we can look at with the accelerometer data is to identify new defects that may not have been inspected. So if you see a particular rough point on the network, it may be that there's new defects occurring there that need inspection to identify them and whatnot. So we can help with that piece of work as well. Looking at seeing what we can do around more predictive maintenance and renewals work and moving a little bit towards asset management planning to some extent, but at the moment our main focus is to try and get that defect management piece down pat and get that under control and a good system for that. But as we're going through it, we're also looking at what data we can use for asset management purposes as well. We're still looking for councils to onboard onto it. We've got 19 on board at the moment. We've got infinite capacity essentially. So any councils that are interested, I'm more than happy to give you a demonstration of it and how it can potentially work for you. This is a bit of a snapshot of one of the dashboard pieces we're working on with Sign. So what you can sort of see is you've got showing changes and what's trending up and down, how much of your road network has defects on it. And then in the bottom part of that, it's the segments of roads that have the highest number of defects on the left and road segments that have the highest number of deteriorating defects on the right. The graph there at the moment in the beta version doesn't display what we want it to display just yet. The objective is on the left-hand side, will show when all the defects have been detected. On the right-hand side, will show those that still remain active on the platform. When we set it up, there's a data flow that we didn't have to enable this to work properly on the front end. We do have the data. We've just got to transfer it across to the front end so we can display it better. As I said, we're looking for councils that want to use the platform. If you want to come on board, you can give myself or William a call. We can run through a demonstration with you. Generally takes us about an hour to run through a demonstration with a council. We can show you the platform, how it works and how we believe councils are getting the best value out of it when they're doing their workflows. So if you do want to arrange a time to catch up with us, you can give us a call or send us an email and we will book a time in with you to run through it. Upcoming events. So we have a Public Works AI Forum on the 21st of August 2026 at the Tech Lab at UTS in Sydney. So that is focused on the use of AI in public works and how you can use the tools that are available today to improve your decision making, to improve your efficiency, things along those lines. We're also looking at the governance risk of it to give you some indication of how it might have to be adopted by council. Our keynote speaker is Victor Dominello, so he will be there to talk to his views on the digitization of infrastructure and where he thinks AI is going. This report used a lot of information from the Road Asset Benchmarking Survey. So whilst I had a lot of defect data and I pulled some questions from the councils, I relied a lot on the data from the Road Asset Benchmarking Survey. The next round of that is happening later this year in September. So I would encourage any councils that are on board to participate in that because it makes this sort of analysis a lot easier for us, and we don't have to annoy you again for other data. And then our IPWA chapter meetings are starting from the 1st of December. Mine in the New England is in Tamworth on the 21st of October, I think it is. So yes, if you are in the area, please attend one of the chapter meetings. They're a great peer exchange opportunity. You meet your colleagues from other councils, and you'll probably get to meet David Elliott as well, which will be the highlight of your week. Beyond that, I finished quite early. I'm sorry, or I'm happy. You're welcome. I don't know. If there's any questions, please let me know.
Thanks, Nathan. Yes, if you do have any questions, please do pop them in the chat or the Q&A. And as Nathan said, he and Will are certainly available for anyone who wants to have a more detailed discussion around asset AI and how it can benefit your organisation. So I'll just give people a little bit of time to pop their questions in the chat. Nathan, I know you're presenting at that AI forum in next month. So what are you sort of planning to focus on at that event? It's a bit of a teaser for people who might want to come along.
Sure thing. So what I'll be presenting at the forum next month is how to use tools, what AI tools are out there that engineers can use in their job day to day, and how to use them. I've done it a couple of different chapter meetings so far, and there's one tool that no one is really aware of. So that's something that every engineer I've spoken to that I've presented this to has said, I'm using that now to help me do my job. So I won't tease it out here because that's the whole point of a teaser. But that's what I'm focusing on. So I give a bit of an overview of what AI can do. There's machine learning opportunities for asset management that I think no one's really looking at too hard at the moment, but you've got to have the data behind you to get it.
Thanks.
Sonage, are you considering ingesting other data sources like Compass IoT? So we're aware of other data sources that Transport for New South Wales has available that we could potentially ingest into the platform. So I'm aware there's some fleet data we could potentially pull from Transport to do some collections. It would be more focused in the Sydney basin, and we are looking at other camera suppliers as well to bring on board. At the moment, we use Shepherd, Retina, and Vaisala. We're looking at other options as well. We've got 2 that we're working with at the moment, but we're not yet sure which one we'll run with for that stage. Bavek's asked if there's a publication. Muskan's put it into the chat. The publication is available on our website. It is behind a paywall. It is a members only document. So yeah, you can download it from online. Stephen has asked, what are your thoughts on this AI data replacing comprehensive condition inspection for road assets? It's a fantastic question, Stephen. It's one of the things we have been looking at as an option. At this stage, I would say the tech isn't there to be a comprehensive replacement of the likes of the old laser profilometers and the ARB or NTRO trucks that drive around your network and do very, very detailed inspections. But we're looking to potentially use this data to fill that gap, because obviously those are very expensive. We believe there is an opportunity to use the data we collect to provide interim condition assessments across your road network to give you that data in between those long periods. So it is something we're investigating, or we've got on our list for a later stage. We're not doing the investigation just yet. We did a proof of concept late last year on it to use the images that we have to determine a condition assessment of a road network. It was promising, but it needs more work and investigation to get something that has a high level of confidence.
Great. I think that might be all of the questions. So I know we have finished a little bit early. Look, I'll take a little bit of time now. If anyone does have any other questions they want to pop in the chat, please do so now. Look, as Nathan has mentioned, we do have a couple of events coming up. So certainly, please do have a look at those on the website. And we'd certainly love to have people along to the AI forum. This is the first time we've run this event. We're hoping it certainly is tapping into some interest from the membership, and the intention is that this will be an ongoing one that will run every couple of years, just to sort of keep everyone abreast of the changes and developments of AI and how it impacts the industry. So, look, I'm not seeing any more questions coming up, so we might call it a little bit early and give everyone a bit of time back in their day to have their lunch. All right, David's got a question.
I just want to make the point, Josh, to anybody that is seriously looking at this and wanting to have engagement with us, that the Prime Minister only an hour ago has announced the new Office of AI, which appears to be something that, ironically, Josh and I had been talking to the state government, the state opposition about for the last 3 years. And it'll be good because Victor Dominello speaking at that forum coming up, he was the minister responsible for digital data when he was in the previous coalition government here in New South Wales. So it is very, very pertinent. It's changing rapidly. Familiarise yourself, if you can, with what the Prime Minister's announcement has been made. But from what I can see, it's a great leap forward, to borrow a Chinese communist phrase. And I think that we're going to find that we will have more and more engagement with government on particularly the state and Commonwealth government, but also the Commonwealth government on this. And it's probably going to be front of mind for the next couple of months when it comes to government policy.
Great. Thanks, David. And yeah, I think the takeaway there is, guys, this stuff's out there. It's not going away. Let's try and embrace it and use it. And really what Nathan's highlighted today is a tangible benefit through the use of this technology. All right, well, look, let's wrap it up there. Thanks all for the comments in the chat as well. The next RTD webinar, we're still finalising the exact topic. It will be either on the upcoming asset benchmarking survey, which Nathan has alluded to, or we have a group of students we're working with who are developing another AI-based solution that we're trying to get them to present it. So keep an eye out for more details of those once we lock it in, and we'll hope to see you at that webinar next month. Thanks all.